Okay, hello everyone, it's Salar and we are in part 40 of our tutorial, a tutorial to writing a real-time operating system. Now we have a short part and I want to talk about queue and stack in this part. But in previous part, I implemented and I talked about single linked list and double linked list. Two types of linked list and two types of data structures that we want to use in our operating system. But as I said in previous part, in this part I want to get into stack and queue, and I want to talk about implementation and usage of stack and queue in this part. But I don't want to implement stack and queue as different data structures, but I want to implement stack and queue by using of linked list. Let's to see the repository of project. As you can see in data structure, we have two subdirectory. Include that in include we have queue and stack, but in source we don't have queue and stack. Okay, because I don't want to implement these data structures as a specific data structures, and I want to implement them by using a single linked list and linked list. Okay, so let's go here and include and back to slides. So first about stack. I want to implement a stack by means of single linked list, but let's do another time talk about a stack. We talked about a stack concept in ARM assembly programming. Okay, but another time I want to talk about concept of stack. A stack is a LIFO, last in first out. Last in first out. LIFO is concept of stack. A stack data structure is a LIFO data structure. Concept of stack is being LIFO. The stack is a LIFO data structure, and you can delete most recently inserted okay, node from your stack. Last in means most recently inserted node. But we have two main operation in a stack: push, as I said, push, writing in stack, and pop, reading from stack. You can use insert first in single linked list to push a data in your stack, and delete first, most recently inserted node, to read from a stack and delete a node from your stack. Okay, so as you can see here in stack, I implemented my stack by using a single linked list, and stack is a single linked list type and stack node is a single linked list node. Just like single linked list, you can create a node by single linked list create a node. You can create a stack by single linked list create new list. You can push your node in a stack by using a insert first, and pop by delete first, most recently added. Okay, and you can search an element in your stack and by element, and search a node in your stack by key. Okay, get size and get top node in a stack is most recently added after new node is first node and is most recently added. Top of your stack is most recently added and most recently inserted node in your stack. But there is a difference than what we saw in ARM assembly programming. The top word in the stack in ARM assembly programming was oldest word that inserted in stack, but here is most recently inserted node in the stack. But this difference is not important because, as I said, the concept of stack is LIFO, last in first out. Okay, in a stack you can delete most recently inserted node. It's the concept of the stack, not where is your stack top. Okay, so let's see an example in Eclipse and see an example in a stack. Okay, just like previous part, I want to insert some elements in my stack. Okay, but before to using stack, you need to include this header file in your code. Okay, data structure include a stack in this directory. Let's show you this directory. This directory that's been downloaded from GitHub. Okay, so here in my main function I have three elements: string 1, string 2, and string 3. 1, 2, 3, and I want to insert this string in my stack. After that, a type of my stack. Define a pointer variable for my stack. 3 nodes for 3 elements. 3 nodes for 3 elements. Configure board and create a stack, like create new lists, and put the pointer in this variable. And after that, first create a node from element 1 by key 1 and put that in the node 1 and push or insert your node in stack. First insert 1, after that insert string 2, and last insert string 3. And after that, according to the size of your stack, okay, pop all of your inserted node in the stack and print the element, your string in terminal comport. Okay, so first add string 1, after that add string 2, insert string 2, and in the last add string 3 in your stack and pop them. Okay, let's debug this project and see the result. Okay, here I want to run my code to the while here. Okay, and I want to print some string in terminal comport. Open terminal, open your comport and run your code. So as you can see, first I added string 1, but you have 3 as the first popped node or first popped element. Last in 3 is last inserted node, last inserted element, but first out. LIFO. Okay, a stack is a LIFO data structure. So simple. So let's go back to the slides and talk about queue. So in this time, I want to implement queue by using a linked list, not single linked list. I can't implement queue by single linked list because I will say why. So queue is a FIFO data structure, first in, first out. You can delete oldest inserted node. Okay, you can delete oldest inserted node. It's the concept of queue. So we have two main operations in a queue. Enqueue, write a node in a stack, insert a node in a stack. Write in queue. Enqueue is write in queue, and dequeue, read from queue or delete from queue. So you can use insert last for enqueue and delete first. Okay, so in this way you can delete or read oldest inserted node in your queue. Okay, for example, assume you have a queue, you can add node 1 here, node 1, and if you want to add node 2, you can add node 2 in your list in the last, and node 3 another time in the last, but delete first, delete 1 to dequeue oldest inserted node. Okay, so here in my data structures I have a queue that's implemented by linked list. Okay, queue is a linked list, queue node is a linked list node. Another time, create new node in queue, create new node in linked list, create new queue, create new linked list. Okay, enqueue, writing in queue, linked list insert last, this node last part of this queue, dequeue, read from queue, linked list delete first. Or you can, because in linked list you can delete any node that you want, and I've implemented the queue by linked list, you can delete any node that you want in your queue, okay, by using up this function. Okay, after that, search a node by element and search a node by key in your queue, get size, get head, first node in your queue. What's first node? What's first node is oldest node in your queue. Okay, and some other things, for example, get next node and get new node. Okay, here is not so important. These functions has some usage in implementing our operating system and make our implementation easier. Okay, but let's see an example about queue in Eclipse. Okay, another time in Eclipse I want to use queue. Add this header file in your code, queue.h, like before, 3 elements, 1, 2, 3, create a variable for your queue, create a variable for each of your nodes, configure your board, and create your queue. Okay, but here, create node 1 from string 1 and enqueue or insert your node in your queue. Okay, after that 2, and in the last insert 3, and like before, dequeue them according to your size and write the string in terminal comport. Let's debug the project. Okay, another time, clear your terminal and run your code till this while and print the strings in terminal comport. Okay, here in here first 1 after 2 and in the last 3, first in string 1, first out. Okay, unlike stack, first you have 1, first in, first out. Okay, here is a FIFO implementation of FIFO, and here is an example. So this was a short introduction about queue and stack, and queue and stack is another other types of data structure that I want to use to implement my real-time operating system. Thank you very much to see me, and see you soon in the next part. Thank you very much.